Hi, this is a talk that actually I've already recorded twice. I did it for the chemistry group because I'm helping out with that one around some of the syllabus content. And I recorded it for the physics group, and then the video file corrupted and I have to do it again. Hopefully that means I'll be close to perfect on this one, but maybe, maybe I shouldn't raise expectations. So talking a little bit about how we assess in senior, and particularly how that's different from junior. I'm assuming that your assessment in junior is under control, that you're happy with that, the how and the why and so on. So I'm going to talk a little bit about kind of the mechanics, but also a bit about how and why we do what we do when assessing in senior physics. In assessment in science education, we are assessing multiple things. As you realize, there are the three strands of the syllabus, the content knowledge, the process skills, and the attitudes and values. In senior secondary, the criteria are that knowledge and conceptual understanding, the investigative processes, and the evaluating and concluding. So we're really kind of examining all of those things, not just the content knowledge. I really encourage you to use some self and peer assessment. Self-assessment of students gets them thinking in terms of what is a good performance, what are the criteria. So your criteria sheet is rich and important, and we'll talk about that in a bit, about what makes a good criteria sheet. But it gets them beyond thinking, guess what's in the marker's head and try to give the marker what they want so I'll get a good grade, to thinking, what actually constitutes doing well, understanding, demonstrating my understanding at a high level in this topic. So it gets them in metacognition, thinking about thinking and learning about learning. It gets that higher level thinking going on. Same thing with peer assessment. It gets them thinking about, well, how do I judge somebody else's performance or demonstration of their knowledge, and how do I know whether it's a good, high quality performance or not on these particular dimensions. You might worry that students assessing each other's work will just, mark their mates high and their enemies low or whatever. But there's actually a bunch of research that's been done around peer assessment that shows that students are actually really good at it, and that the correlation between the marks that the students give in peer assessment and the marks that expert markers give is extremely high. That students actually do a really nice job of marking. So I'd encourage you to use some self and peer assessment, self and or peer assessment in your assessment bundle. Performance assessment is maybe one that's specifically, well, I was going to say it's specific to the sciences, but of course in something like drama you would assess a performance. So there are a number of other domains in which a performance is relevant, dance and music and so on. So in science, because there is that inquiry, investigative skills aspect, investigative processes and skills, the ability to actually do something in the lab is something that we want to be able to assess. If we value it, if we think it's an important part of the learning, then we ought to be able to assess it. So my favorite example is actually chemistry rather than a physics one, but if you get a student to do a titration where they have to work through the titration and explain why they're doing what they're doing. So, okay, now I'm taking the burette, I'm rinsing it out with the solution that's going to go in the burette. I'm choosing to do that rather than with water because here's the reason. I understand what I'm doing. I'm rinsing the flask that the titration will go into. I'm doing that with water rather than with the solution. Here's why. I understand what I'm doing, right? So you're not only looking at the physical performance, you're looking at the mental investigative skills process. That do the students understand what they're doing? You might use video, although I would warn that video is quite time consuming. If you get videos of a whole class of students, it will eat your whole weekend to sit and watch those videos and mark them. So you might then use some peer assessment or some other kinds of mechanisms. There's a variety of ways that you can do this, or get a student teacher to help you with this task, or get parents to come in and help you with it, and so on. So there's ways to get other adults into the classroom as well as part of your assessment package, train them up and get them to be judging the performance of students. But performance assessment is a piece that's important in senior secondary assessment. Across the senior secondary syllabus documents, all of them do EEIs. All of them do something like a supervised assessment, which is basically a test, exam, quiz, etc. The biologists are being a little bit contrary and call it something different, a written task rather than a supervised assessment. Chemistry and physics use the same terminology, and Science 21 kind of has a bet both ways and calls it a supervised written assessment. Chemistry and physics, as you can see, are basically identical in terms of the way that the kinds of assessment tasks they use. So the extended response task, the ERT, the assignment report type thing is the same for both of those. In biology, they just call it an extended response. Science 21 uses the extended response task, and Science 21, which is the multi-strain science, also uses a collection of work, so a portfolio over the years that the student keeps and the student curates and comments on. So this is a demonstration of my knowledge at the beginning of year 11. This is a demonstration of my knowledge at the beginning of year 12 when I've learned a lot more. So that's a nice piece, but it's not a piece that we use in physics. Just a quick rundown of the pieces. The syllabus contains lots of detail about what these bits contain and how to do them and so on. There's lots of information around. But an ERT, an extended response task, is a report or an article. You could get them to do probably not a scientific paper, but certainly a article for something like Scientific American or some kind of popular science thing that talks about the science that they're learning. They use secondary data, so they go to the library, or the library pretty much these days is in the computer, so web searches, but that also implies they need to know how to judge good web resources from bad web resources. How do you tell that this is coming from a quality site and that it's a credible source? So that's part of this process of developing that critical judgment, appropriate referencing and so on. You assess all three exit criteria: knowledge and conceptual understanding, investigative processes, and evaluating and concluding on an ERT. The length requirements, I should have changed the order around. EEI, the length requirements are about 800 to 1,000 words for a year 11 and about 1,000 to 1,500 words for a year 12. So that's a reasonable sense of the scale of what these things should be like. They really shouldn't be doing 20,000 word mini doctoral theses at this stage as a task. And really more words is not better. More concise can actually demonstrate knowledge better than something incredibly verbose and big. So 1,000 words is kind of a manageable size task for year 11 and up to 1,500 for year 12. And assessing all three assessment criteria, having a good criteria sheet, which we'll talk about in a bit. For a supervised assessment, exams, tests, quizzes, you can use multi-choice or short answer or mini essays or full essays, I guess. We tend not to use those so much in physics. Calculations, certainly there's going to be a fair few calculation type questions examined in a physics program. Short responses, you can do the exit ticket thing, get them to write a paragraph about what they learned today before they leave class as kind of a formative assessment. An essay can assess 1, 2, or all three of the exit criteria. So different tests and quizzes will access and assess different of the exit criteria. You might give them a stimulus piece. Here is a very short article, read through it, find out what's right and what's wrong about it scientifically. Are these claims credible, and how do you know? What physics knowledge are you drawing on to make that judgment? So that's kind of evaluating and concluding strand, and so on. As I say, you don't often do essays, but you might do an explanation of a concept or something of that nature, where students have to maybe apply their knowledge of electric circuits, alternating current, transformers, fields to household power generation or whatever. So they're describing a particular context and demonstrating their physics knowledge. EEIs, extended experimental investigations. I think I already said that these are a really cool part of Queensland physics that I hope we'll get to retain under the new syllabuses. I think we will. I'm reasonably hopeful, but it's too early to say for sure whether we'll have them or something quite like them under the new syllabuses. Student planned, conducted and analysed. That's kind of important, that it's not you giving them a lab sheet and them going through it. That doesn't constitute an EEI. A big part of it is their ability to design an experiment. They generate their own primary data in the lab and use it. So ideally you're finding a scope where they can't just do one experiment, one lab session and they're done. And it's not also something that's going to take 5 years to see results. It's something that in 4 to 6 weeks for your actual unit, they're going to be able to generate some data, analyze it, write it up, and describe it. 4 weeks is the minimum that you can do to that you can devote to doing an EEI in your class. I've seen people do them 6 weeks or 8 weeks. I would encourage being careful not to waste time. I see often in classrooms a lot of students milling around, chatting, messing about, and the teacher says, well, they're working on their EEI. Well, are they actually getting something productive done? Or would it be better to actually have the lab sessions and maybe be teaching some content at different stages around it, maybe be doing various other things so that time is actually used in an efficient way in the classroom, getting them to do some of that writing up at home rather than in the classroom, particularly if they want to do it on computers that they don't have in the classroom. Yeah, there's a whole variety of things, but forward momentum, making sure that it feels purposeful and positive rather than just, okay, this is the 6 weeks of the year when we just drift and cruise along. We give them more scaffolding at year 11 and less scaffolding at year 12. We support them by helping to design it, giving them some tips about how you design an investigation, which of course they've been doing in junior secondary and you've been doing in junior secondary. We spend some time, we will give them more detail on the assessment. We might suggest topics at year 11 that we won't at year 12 and so on. So there's a level at which they are getting more independent as they go from year 11 through. An EEI assesses all of the exit criteria, and we talked about the length requirements before. Those time requirements, 5 to 8 minutes, 8 to 10 minutes, are if you get them to do a video or a talk to the class or some kind of other presentation rather than a written piece. That's a really nice way to do it. It tests different things and gives them different skills and so on. My kids mostly grew up in Canada where they do a lot of presentations to the class, and they, as a consequence, are very confident public speakers and very comfortable with that, whereas Australian kids, where they don't do as many presentations, sometimes tend to struggle with that more. But at the same time, for marking, same issue. If you've got 30 or 20, however many you have in your class, 10-minute videos, that's a chunk of time that it's going to take to actually kind of mark those. And also for verification, to go in the folio, the panel is not going to sit there and watch a number of videos. Usually, they're more likely to want something written that they can assess at folio. So thinking about the cost-benefit analysis, I guess, really, of using presentations for these assessments. So the exit criteria, and again, I probably should have talked about these before, and I have been, but here's the slide. So knowledge and conceptual understanding, the content stream, if you like, the parallel to the SU, science understanding stream of the junior secondary curriculum. Investigative processes, which sort of parallels the SIS, the science inquiry skills in the junior syllabus. Well, it pretty much does, but the parallel kind of breaks down. Evaluating and concluding is related to the SU, the science understanding strand in junior secondary. But science, sorry, the science as a human endeavor. Sorry, Su, Sis, and She. The science as a human endeavor is about the nature of science, about linking science to technology, to human endeavor and activity, and so on. Variety of things around that. And evaluating and concluding is similar, but it also is more sciencey, less humanities-y, if that makes any sense. It's more those higher levels of Bloom's taxonomy, where they're doing evaluation, synthesis, and creating new stuff. So the knowledge and conceptual understanding is more that kind of conceptual recall and use at the lower level of Bloom's, and the evaluating and concluding is the higher levels of Bloom's. But it does also have that social dimension, the ethics of using particular sciences, say nuclear power and so on. So, as I say, the parallelism between junior secondary, the Australian curriculum science, and senior secondary is there, but not absolutely direct. Criteria sheets, it's important that they be good because they are public documents. They are what help the students recognize what constitutes a quality performance at a particular standard. So a criteria sheet should have A to E for the various criteria. So criteria as rows, grades as columns, specific info, clear descriptions, chances to self-evaluate. So does it give them enough information to be able to judge their own performance? So on this assignment, I think I've done about here on the criteria sheet for this criterion, but only over here on this other criterion. So I need to improve that dimension of my assessment. And it's really helpful for you in making judgments and defending judgments at moderation or monitoring moderation and verification panel processes. It's very helpful as well if you get sick and someone has to come in and cover your class, that they have to make judgments. If you want to get someone to help you with your marking, if they have to make judgments, and so on. So it kind of helps everybody if your criteria sheets are of high quality. There are specific things that go into the verification folio that the student keeps for the teacher keeps for each student through the whole 2 years. So this is a building up process of keeping assessment tasks with the criteria sheets, with the judgments that have been made about those assessment tasks, so that you can demonstrate. This is part of this Queensland internal assessment process. So we've got, rather than an externally set exam, we currently have all internal assessment within schools, but we need to be able to guarantee, to the extent that we can, that a high achievement on the Gold Coast and a high achievement in Mount Isa or Townsville is the same thing. So we use various moderation and verification processes to ensure that. So in the verification folio, lots of detail on the syllabus on that. So I'm kind of just giving you a quick rundown of bits and pieces. You need evidence in relation to the 3 exit criteria and to make judgments about those. And students will have should have multiple opportunities to demonstrate the criteria across the 2 years. So they should be able to do something in year 11 and do something similar in year 12. It might be with a different content topic. It might be with coming back to that content topic at a higher level, but they have multiple opportunities to demonstrate what they know and can do. So here are the bits that are in the verification folio. So your assessment instruments that you've used across the 2 years, at least 1 but no more than 2 EEIs. So you're required to do 1 EEI at year 11 and 1 at year 12. You could do more if you wanted to, but you can't include more of them in the folio, just 2 as a max. But you have to have at least 1. At least 1 of your supervised assessments, tests, quizzes, and so on. You could include more. At least 1 year 12 contextualized unit of work assessment task. So again, you're required to teach 1 unit in context at year 11 and 1 unit in context at year 12. And from that contextual unit at year 12, you need to have an assessment task that goes into the verification folio. The criteria sheets for all of the assessments, and we've just been talking about what constitutes good criteria sheets. There's lots of help out there to find good ones, and you can borrow and adapt and adopt, steal from the best. And a profile, in other words, a summary of all of these judgments that you've made over the years, but it's not a set of numerical scores that you then average up at the end of the period. It's a judgment about the levels at which they've met each of the criteria. So that'll be an A to E, and then those are all brought together. The other piece is fullest and latest evidence. So the syllabus says the judgments at the end should be made on the fullest and latest evidence. So that means that things that the students have done towards the end of year 12 way more than things that they did at the beginning of year 11, because they've been developing as physicists over that 2-year period. So it doesn't mean that the stuff they do in year 11 weighs nothing, but it weighs less than the latest evidence, if that makes sense, in making those final judgments. We're also required to do 1 assessment post-verification. So the verification folio goes off before the end of the year so that those processes can take place. And obviously you're still learning and teaching back at school, so you're required to have at least 1 more assessment task that's completed that ideally includes all exit criteria, all 3 exit criteria, and that goes into the exit folio for the student that doesn't actually go to the verification panel. So there's 1 extra piece after the verification process. So hopefully that's relatively clear. This is something where working with colleagues who are working in the school, you may well have colleagues at your school or a neighbouring school who are actual panel members and can talk to you about the various forms that are used and so on. As I mentioned earlier, I haven't taught in Queensland, so I haven't mechanically done this process. I understand it from the syllabus, but talking to someone who's been integrally involved in the process is going to give you a lot of understanding of what's going on with assessment in senior secondary.